Let me give you a quick summary of what we've done so far, and then I will give you some practice. So in the past we were trying to work out this series. In the past we were trying to sum up everything, but we have no idea how we would go about summing up this whole thing. So we would create a scenario in such a way that this will be true. We would use Riemann's upper sum to represent this. So this area here would represent this. This area here would represent this. This area would represent this, and so on. So that led us to this. So that led us to this, where the area underneath the red line, so the integral of the graph 1 over x, must be less than this whole thing here. So by using some manipulation, it gave us this thing here. So when we got to this stage here, we would take the limit as n tends to infinity, take the limit as n tends to infinity. Well, this represents the area underneath the 1 over x graph. Well, the area underneath the 1 over x graph diverges. So it diverges. Well, this area here diverges as n tends to infinity. Well, this being greater than this thing here, we have no choice but to also diverge. The point I'm trying to make here is that we were trying to understand this. But then we would use the area. We would use the integral from 1 to infinity of 1 over x. We would use the area underneath the red line to try to understand this. And by the way, the whole summation here is not the same as the integral from 1 to infinity of 1 over x dx. The area underneath the red line is not the same as this thing here. This thing here, well, most of the time the summation is very difficult to calculate, but then we would use the integral to try to understand this. We don't know how to sum up this thing, but we would use this thing to try to understand whether or not this will converge or this will diverge. And this we've done all this in the past. And then we could also make use of Riemann's lower sum. So this thing here would represent this. This thing here would represent this. This thing here, and remember, this is we've done all this before in the past. So using the Riemann's lower sum, that then gave us to this. That then led us to this, and then from here we would add equally to both sides. So here you've got this thing being less than this thing. From here we would add an equal amount to each side. Let's add 1 to each side here. 1 to each side. So now we've got our whole series, but then we would make use of this to try and understand something about our whole series. So that's a summary. So in general, now it's your turn to have a go. Try and find the try and establish whether or not this will converge or this will diverge. By the way, this thing here is it's very difficult to sum up everything. Our mathematics is not good enough to sum up this whole thing. But what we can do is make use of the integral from 1 to infinity of 1 over x squared dx. We can make use of this to try and understand this, because at the moment it's very difficult. Our mathematics is not good enough to try and sum up everything. So we would make use of this to establish whether or not this whole thing will converge or if it will diverge. Okay, so try to establish if this thing here will converge or if it will diverge. Use Riemann's upper or lower sum. You have to decide for yourself. You've got to decide whether or not to use. Well, establish if this will converge or if this will diverge. I will explain it. I will show you how it's done in the next video. Okay.